Hello everyone, in this video we'll be continuing our discussion on pointer arithmetics. So now we know that we can access array elements using such a notation, but how are we to do it if we want to use some arithmetical operations on the pointer? From our previous discussion, we discovered that ARR plus 1 actually refers to the address of the first indexed element. ARR plus 2 would refer to the address of the second indexed element. So by dereferencing them, we should be able to access the value present at that index of an array. So the effective equivalent of accessing an array element using square brackets, but if we try to do that with pointer arithmetic, would be something of such sort. In this way, we can access the same array element, but here we are using our arithmetics on our pointers. Now, let's talk about something which will help us to further understand how we will achieve the similar behavior, but for multidimensional arrays. Before that, let's discuss what a pointer to a pointer is. So we know that int star ptr is equal to address of a if int a is defined. What this effectively does is ptr is now pointing to an integer data type variable. Now, is it possible that since ptr is storing just an address of a pointer, is it possible that we have another pointer which can store the address of this ptr? Yes. Such a pointer is called a pointer to a pointer or a double pointer. How we define it or declare it is using int star star ptr2 is equal to address of ptr. So dereferencing them will also work in a similar manner to what you would expect for normal pointers, but here we can go a little deeper. So let's try printing ptr2 followed by the address of ptr, which we have actually assigned it to. Now we use the star operator on ptr2 once, and let's see what we are observing. If ptr is storing the address of a, we know that star ptr effectively results to a, meaning star ptr will refer to the same values which a is referring, and any changes made to both will be reflected for both because ptr is directly accessing that memory. So in our case, since star ptr2 is accessing since ptr2 is accessing the address of ptr, star ptr2 should be able to give us the value of ptr. So there should be no difference between star ptr2 and ptr. Going ahead, what if we try to use double star on ptr2? What this should give us? Now since star ptr2 gives us ptr, which is nothing but address of a, we can expect star star ptr2 to be equivalent to star ptr, which is nothing but a. Let's just solidify our findings, or what we expect to find using these three print statements. So I'll initialize some value to a as well. 1. Right. So we observe that ptr2 and address of pointer ptr are the same. Star ptr2 is nothing but the value stored in ptr, and star star ptr2 and star ptr are the same as accessing the variable a, or accessing the value stored in variable a, which is 1. Now why are we learning this? When working with multidimensional arrays using pointers, what we will be working on are double pointers most of the times, especially when we try to create our own dynamically allocated multidimensional array. For now, let's just see, similar to what we did for a single dimensional array, where we use arr plus I to get the ith indexed element of the array. Let's see how we can achieve a similar behavior or if there is a way to achieve a similar behavior for our multidimensional array. So in general, what we know is that for a multidimensional array of arr I and j, so basically it has I rows and j columns. If we try to access the ith element or the jth element, let's see how we can do that. So in order to access the I and j, ith row, jth column of the given multidimensional or two-dimensional array in this case, the effective equivalent of what we did for a single dimensional array would be star of arr2, or the array name, plus I plus j. So arr2 of I j is effectively equal to this. What we do, since arr2 will store the address of the first array itself, we move it to the ith row. So if I is 0, we remain at that element. If I is 1, we move it to the next element, and so on. After we've come to that address, what we do is we dereference it so that we are able to access that first element of that given row of the multidimensional array. And then we move it j places further to go to the jth column, whatever we require. And then we use a star operator to dereference it. So this is how we use pointer arithmetic to access values of variables for given indexes in different types of arrays. Now let's quickly also go over how we can dynamically allocate memory to a two-dimensional array using pointers. So here in star ptr is equal to new int of 10, what it does is it will go to the memory, it will find 10 spaces where each space occupies the memory of one int, and it will club all those it will give the starting address of that given blocks or chunks of memory to ptr. And star ptr will be nothing but an integer value. Now from this example, or from this two-dimensional array, what we can see is in a two-dimensional array, each array element itself is a pointer. So say if I had a pointer ptr1 which is pointing to the array 1 2 3, what this effectively would boil down to will be this being replaced by ptr1. Similarly, something like this will also be replaced by ptr2. So what we observe now is a multidimensional, or in this example, a two-dimensional array is nothing but an array of pointers themselves. So for a normal integer, for a normal integer array, each element is an integer. For a two-dimensional array, each element will be a pointer. So since for the example of ptr, star ptr will be an integer. So if we what we want in a two-dimensional array is we want as many number of rows. So let's say we have 5 rows, right? So we'll have 5 arrays. 5 arrays means 5 pointers. Basically what we want is, initially we want the space to be to store 5 pointer variables. How we do that is using int star of 5. So as discussed before, new int of 10 will make 10 integer, like it'll take the space of one integer, and we want 10 such spaces contiguously. It'll find such a place, it'll allocate it to ptr. In our case, what we want is we want five pointer variables to be stored contiguously. So what compiler will do now is it will go to memory, it will look for 5 such contiguous places where each space will be equal to the memory occupied by an int star type of variable, and then this needs to be assigned to a pointer. Here we see star ptr actually stores int. Now since we are storing integer variables, we are storing integer pointers, our resultant or receiving pointer will be something of the type int ptr2 is equal to new int of 5. So this is how we initialize the first part, which is this will tell us how many rows of pointers we need. So in this case, we want 5 rows of pointers. And for each row of the pointer, int I equal to 0, or each row of 0, we have 5 rows. What we then do is, now that we have places for 5 pointers, what we then go and define is we assign memories to each of the arrays present. In this example, it will be ptr1, which stores 1, 2, 3, ptr2, it will store some other 3 integers, etc. And we assign those to each of these specific variables. Again, what we do is we go in the memory, we assign memory for these 3 variables together, or these 3 spaces together, and that needs to be assigned to each of the pointer variables present in the 2D array. So how we do that is ptr2 of row. Each row is now again a new array in which each element is an integer. So new int of, let's say I want 5 such numbers in each row, or 6 such numbers in each row. So this is basically how you will create dynamically a 2D array. How do we deallocate? It will follow the same procedure as allocation, wherein we go to each row and each pointer we delete or deallocate the memory assigned to each pointer. So ptr2 of row. Afterwards, when we have deallocated each and every specific memory assigned to a pointer, then we deallocate the memory which was given to our double pointer, basically, which is our array of pointers, which is ptr2. So in this way, we are able to create or dynamically allocate memory to a 2-dimensional array, and we are also deallocating the same. Thank you.